The 767 flight controls are positioned by hydraulic power control units, or PCUs. Therefore, all 767 flight controls are hydraulically operated by PCUs and do not have manual reversion. Control cables provide manual control inputs to the PCUs. The PCUs can also receive input from the autopilot servos. Notice that all three hydraulic systems provide operating pressure for the elevators and rudder. Also notice which hydraulic systems provide pressure to the inboard and outboard ailerons on each wing. The center hydraulic system supplies pressure to all primary flight controls, with the exception of the outboard ailerons. Accordingly, the center system can be pressurized by a number of different pumps, including a ram air turbine. In case of a dual engine failure that could render all engine-driven and electric hydraulic pumps inoperative, the center hydraulic system is equipped with an automatic deploying ram air turbine, or RAT. The RAT operates a hydraulic pump that produces emergency hydraulic power for the primary flight controls portion of the center hydraulic system. The secondary flight controls consist of a horizontal stabilizer, spoilers, leading edge slats, and trailing edge flaps. Stabilizer trim is normally powered by left and center hydraulics, while slats and flaps are normally powered by the center hydraulic system alone. The spoiler panels are each powered by an individual hydraulic system. Note the diagram shown here. This frame shows the controls and indicators associated with the flight controls. Move your cursor over each highlighted item to view a description. The rudder provides directional control around the yaw axis. The rudder is hydraulically powered by all three hydraulic systems and controlled through the rudder pedals. 2 yaw dampers operate through the rudder control system to improve yaw control. Movement of the rudder pedals is transmitted via cables to 3 rudder hydraulic actuators, one for each hydraulic system. The status page displays rudder position. On the ground, during the test of the flight controls, hold the tiller when pushing either rudder pedal. Pushing the rudder pedals to their stops displaces the rudder to its maximum deflection and causes a full-scale deflection of the pointer from the neutral mark. Rudder trim is available through the rudder trim control knob located at the aft end of the aft electronic control stand. Application of rudder trim causes an electric motor to reposition the rudder neutral and indicates the rudder trim position in units of trim on the rudder trim indicator. Note that rudder trim input also displaces the rudder pedals from neutral. A rudder ratio changer modifies rudder pedal and rudder trim inputs as a function of airspeed. As airspeed increases, the ratio changer desensitizes the pilot inputs to reduce rudder deflection. The ratio changer operates through the left hydraulic actuator. Therefore, the actuator assists or dampens rudder pedal input to the rudder depending on airspeed. If the ratio changer is inoperative, the left hydraulic actuator shuts down. An overhead panel rudder ratio light and an ICAS advisory message of rudder ratio display to indicate a failure of the rudder ratio system. A failure may come about because of a ratio system failure, the left hydraulic system failure, or the associated air data computer failure. In case of a rudder ratio component failure, rudder structural protection should be provided by the automatic depressurization of the left hydraulic actuator. Thus, the shutdown of the left hydraulic actuator will naturally limit rudder displacement at high airspeeds, since only 2 actuators remain operative. Even so, abrupt rudder pedal inputs need to be avoided at high speeds. At low airspeeds, the other 2 remaining actuators are sufficient to provide full rudder displacement. Check your manual for the available auto-land operations and crosswind landing limits with these possible conditions. Two independent yaw dampers handle aircraft directional stability and turn coordination. The left and right yaw damper actuators are powered by the left and center hydraulic systems, respectively. A yaw damper switch in op light illuminates, and an ICAS advisory message of left or right yaw damper displays to indicate an inoperative yaw damper. At least one inertial reference unit must be operational for the yaw dampers to function. Therefore, it is normal during pre-flight for the yaw damper in op lights to be illuminated until the IRS is aligned.